Good morning, students. Am I audible? Okay, ask your friend to join quickly. Okay, inform all okay to join. Okay, can we start? So this is a continuation class of yesterday. So yesterday we were discussing about creep, right? Remember? So in the last class we have discussed about what is creep, how creep occur in a railway track, and different theoretical approach or theoretical method to explain the cause of creep. Okay. So first of all, let me just go for a revision of that previous class. Then we proceed to that. How can we remove creep from railway? Clear? So first, let me allow to share my screen. My screen is visible, right? My screen is visible or not? Okay. So what is creep actually? We have already discussed that it is a longitudinal. It defined as the longitudinal movement of rail with respect to slipper. Okay. The longitudinal movement of rails with respect to the sleeper in a particular track is defined as a creep. Fine. Okay. And it may vary the rate of creep, or you can say the longitudinal movement of rail with respect to sleeper. The rate of the movement, it may vary depending on the type of the railway track, like the track gauge, okay, or atmospheric condition, and the traffic volume. Okay, fine. and the creep will be more in a particular direction where your traffic, dominant traffic will be in a particular direction. Okay? That means in a particular direction where traffic is high, along that direction, the creep will occur. Fine. So basically, creep is defined as a longitudinal movement of rail with respect to the sleeper. Okay. And cause of rail, we have discussed theories. What are the theories? Your wave action theory, percussion theory, drag theory, starting, accelerating, or slowing down or stopping of a train, expansion or contraction of rail due to temperature, and finally unbalanced traffic. So they are basically, so you can say the cause of occurrence of creep. They are basically cause of occurrence of creep. So we have discussed about wave theory. Okay, so basically what is a wave theory? Uh, it is considered that each wheel creates its running wheel, basically its running wheel creates a wave kind of pattern along a railway track, which tends to move the leading rail in forward direction. Okay, like that, in this direction. Right? So we have already discussed about that wave theory. Then percussion theory basically deal with what? It's basically deal with your this portion, the weakest part of the railway track. It is your the joint. Okay, so we already know that the joint part is the weakest part of a railway track, and when a railway wheel come in contact in particular joint, and when just about to uh, enter in that facing rail or leading rail, it try to push the leading rail forward in this direction. Okay, here you can see the arrow mark also given here, right? This arrow mark you can see. So because of this resultant load R, a horizontal component of load will be in this direction. That means along this direction. So because of that, at this low, this force, it creates a force which tends to move this rail, the leading rail or facing rail in forward direction. So it will create a creep. How? It will create more expansion joint here. The gap will be increased. That means this fastener become weaker. Okay, fine. This is a fishing plate. It become failure. Okay, this cause failure. Then we have discussed our drag and dragging theory. It is basically similar to that first one, wave action theory. But this dragging theory basically deal with the driving wheel of a locomotive. Okay, so when it comes to the driving wheel only, okay, the driving wheel along with the waving action, it also it also acted upon by the sorry, where it is. It also acted upon by the drag given by uh, the wheel of the trailing part of the rail, that is your compartment or wagon. Okay, so the drag or dragging force created by that attached part, that is the passenger compartment or goods carrying compartment. Okay, because of that, the driving wheel of the rail, driving wheel of the locomotive, sorry, it it exerted upon by a drag force. It experiences a drag force, and which is because of which it tends to move. It tends the rail, the forward rail tends to move in the forward direction. Fine. Okay. So after that, after drag theory, we have discussed in general when a particular locomotive just start to move from a stop position, it give a when a train is starting or accelerating, a backward thrust of the engine drive the wheel tends to push the rails backward. Okay, we already discussed about it now. When a wheel start moving in this direction, particularly, suppose this is a rail, it gives a backward thrust in this direction. So it tends to move the rail in backward direction. And when the wheel tends to move in when the strain stops suddenly, actually, when particular rail suddenly stopped, okay, suppose this is moving in this direction, suppose, and suddenly it stopped, okay, suddenly it stopped, then it gives a forward thrust. That means when it is slowing down or coming to stop, the braking effect tends to push the rail forward. Okay, because of the stoppage, it gives additional friction or additional force, and because of that, it try to um, push the rail in forward direction. Okay. Likewise, we have also discussed about the effect of temperature. There is the effect of temperature, how it can uh, increase the expansion gap, or it can also, and somehow it can decrease the expansion gap. Okay, we have also discussed about that. That means suppose there is a three rail connected with each other, giving a particular expansion joint. Suppose this is expansion given, okay, along. Suppose this is a fish plate is connected with the rail. Suppose because of the creep, the expansion joint may expand in this direction. Okay, that means suppose because of the creep, expansion joint may this rail come closer to this. So you can say it will create a additional thrust to this slipper. Okay, so there is a failure pattern will may generate along here, or this will also create a additional expansion gap up to this level. Okay, so because of creep, they also can move, so expansion gap also get increased. So when wheel come in contact, it will get stuck in the gap. Okay, so the expansion gap should not be so high. Fine. So there's a particular reasonable expansion gap we have to maintain. So I have already told you in the last class that you have to find out what is as per IS code, what is the range of expansion joint to be given in Indian Railway. Okay, for different gauge. Okay, like broad gauge, meter gauge, or standard gauge, you can find out. Okay, so these are the effect of temperature. Then we have also discussed about unbalanced traffic. That means I already told you that if a particular railway line is so much busy along a particular day, okay, that means the possibility of creep will be higher in a particular track where the traffic is more. Okay, and a particular in track, suppose your traffic is very less, then there is a chance of possibility of creep is very less. Okay, so you can from this point of view you can understand that particular railway track where the traffic is high, the particular track also required higher maintenance in a time to time maintenance, basically. Okay, so that's how you can identify the creep depending on the uh, railway track profile. Clear? So up to this point we have already discussed, okay, like cause of creep, like we have already discussed, like ironing action of the wheel. So ironing effect of wheels formed in the rail tends to cause the rail to move in the direction of the traffic, resulting in creep. It is actually about telling about the wave action. Starting and stopping operation, we have already discussed about that. When a train start or accelerate, the backward thrust of its wheel tends to push the rail backward. Similarly, when the train slows down or comes to a uh, halt, or you can see the station, the effect of the applied brake tends to push the rail forward. So this in turn causes creep in one direction or the other direction. Okay. So change in temperature we have just already discussed that creep can also develop due to variation in temperature resulting in the expansion and contraction of the rail. Creep occurs frequently during the hot weather condition. That means during the hot weather condition there is a possibility of creep due to temperature variation. Okay. Unbalanced traffic, this is also discussed that in double line section. Double line section means individual line railway track is provided for left or right direction movement. in a double line section, train moves only in one direction. That is, its track is unidirectional. Fine. A creep therefore develops in a particular direction of the traffic. But in case of single line section, that means there is only one railway track is provided for both direction railway movement. In a single line section, even though traffic moves in both direction, the volume of traffic in each direction is normally variable. Okay, it cannot be same. So creep therefore develops in a direction where predominant traffic. That means in a particular direction, the creep will occur in that direction where your uh, your traffic will be moved. Okay, since in both direction the volume of the traffic may not be same. Next, creep can also be created or can also be take a dangerous scenario if poor maintenance of track will be done or maintenance of track is not done properly. Some minor factors mostly relating to poor maintenance of the track also contributing to the development of creep. Okay, these are as follows: like improper securing the rail, the sleeper. That means if you are not fastening the rail to the sleeper, uh, means tightly, so they may get fail. Okay, that you have to make sure that rails are connected to the sleeper. Okay, so we can also use an anti-creep fastener uh, to join to fix the rail with the sleeper so tightly so that creep will not be occur. So we are going to discuss about anti-creep system also. We are going to show you one picture also. Okay, so limited quantity of ballast resulting in inadequate ballast resistance to the movement of the sleeper, of course. So the amount of ballast required is also very important for that. Improper expansion gap also, yeah, of course. So you have to give a proper amount of expansion gap where it's needed, how much is needed. You have to design before going for construction. Badly maintained rail joint. As you all know, rail joint is the weakest part of the railway track, so we have to go for securing the railway joint first, okay, by giving a proper fastening by using bearing plate or fishing plate, okay, keys, all these things you have to be so of good quality and tight it so strongly so that railway track or rail should not um, dispatch or it can should not come out of the fastener from the sleeper. Rails too light for the traffic carried on them. That means we should also be ensure that the rail should be tough enough. Okay, or should be that particular kind that can take the load of the heavy load traffic. Okay, you know that because of the wave theory. As for the wave theory, I already told you that the wheels create a wave kind of moment, right? And if your rail is not of desirable standard, then the wave generation will be high. Okay, then there is a possibility of creep will be higher. Okay, yielding of formation that resulting uneven cross level. So we haven't discussed about cross level right now. Cross level means what? Basically, when your um, rail two railway line cross each other like that. This is a cross level. Okay, so even in that particular point also, we should not be we should be safeguard this point. Okay, I'm talking about this cross level point. Okay, so that the creep should not occur in crossing. Okay, we're going to discuss in coming module. Okay, about crossing points and crossing. Fine. Okay, so effect of creep. Finally, we come to that class. Okay, so this up to this we have already going for a revision. Fine. So what are the effects? Slippers out of the square. That means because of the creep, what will happen? I already told you in the last class also. Suppose before creep occur. Suppose this is a railway track. Okay, before sleep, sorry, before creep, this is your railway track, and they are sleeper. Okay, they are a sleeper. Now, due to creep, what will happen? Due to creep, suppose this rail part move in this direction. Okay, let's move this. Suppose this rail move in this direction. Suppose, fine. Now, because of that, what will happen? This slipper, this I'm talking about this slipper only. This slipper become out of the picture. Okay, it is become useless now. So this slipper, you can say it is out of the square. Okay, the slipper move out of their position as a result of the creep and becomes out of the square. This in turn affect the gauge and alignment of the track, which finally result in unpleasant ride. Okay, so here you can see there is no track or railway track, unpleasant ride. Maybe there is a rail will be there, but gap will be higher, gap will be increased, right? Then when rail move along this, it will give a unpleasant uh, situation for passengers inside the train. Fine. Expansion in gaps get disturbed. Okay, we already discussed, right? When a rail move in backward or forward in a longitudinal direction, in some point the expansion joint or expansion gap increased, or at some point expansion gap decreased. Okay, so due to creep, the expansion gap widen at some place and close at other. This result in the joint getting jammed and undue stress are created in the fish plate and bolt. Okay, I'll show you. I think somewhere there is some. Yeah, here you can see effect of creep. Here you can see. So this picture, basically this picture showing you before the creep. Okay, this one. This is, suppose this is a before a creep. This is one rail part. This is another rail part. Okay, they are fixed with this fishing plate and tighted bolted with this fastener. Fine, and this much the expansion gap is provided. Okay, this much expansion gap is provided. Now maybe in that part, in this direction, or you can say from in that direction, you can say in this direction the creep is occurring, and this rail part move in this direction, and this is a scenario of after creep. Okay, so due to creep, you can see there is, you can see that there is a negligible gap of the expansion joint, and now you can see the failure pattern you can see here. Okay, from the picture also you can observe the effect of creep. So there is a effect of creep. You can see it is may fail the rail part. Okay. Okay, fine. And distorting the point and crossing. Due to excessive creep, it becomes difficult to maintain the correct gauge and alignment of the rail at point of crossing. So we haven't discussed what point of crossing, but anyway, I'm going to show you actually what is point of crossing. But in coming your coming module, we're going to discuss about point of crossing anyway. Wait, let me. Wait. So basically, what is point of crossing? Point and crossing means the particular section of a railway profile or a railway track where the particular train can change its direction. Fine. So even here in this direction, in this drawing, in this line diagram, you can see the point of crossing here. Is it visible or not? Let's find out another one. Anyway, I think it is visual, right? This diagram. Okay, so this particular section of a particular railway track called a point of crossing. Okay, so this point is called point, where actually here you can see this part. These parts represent point. Okay, and this part represent crossing. Okay, that means when a train move in this direction. Okay, at this point, okay, I'll just show. Okay, uh, that means at this point, a particular train can decide whether it want to go in straight direction, or suppose it want to take this particular direction. Okay, suppose it's a right turn. Okay, so that means at this point, how it's going to work in a particular field, we're going to explain, we're going to discuss in coming classes. But anyway, yeah, this is a particular instruction card of point of crossing. So this point represents your, this section represents point, and this point is represent crossing. Okay, so at this point it's finally crossed. Fine. So even in this part also there is possibility of creep. Okay, so because of the action of creep, they get also may get fail of this whole section. Okay, so effect of creep also get damaged or affected in point of crossing section of a particular railway track. Clear? Okay, so due to excessive creep, it becomes difficult to maintain the correct gauge alignment of the rail at point it crossing. Okay, anyway, difficulty in changing rails. If due to operational reason it is required that the rail is changed, the same becomes difficult as the new rails is found to be either too short or too long because of creep. Okay, so because of the creep also, the maintenance of the railway line becomes difficult. Okay, because since due to creep, the rail land may get distorted. Okay, the rail cross section may get distorted, land also get distorted. Now if suppose you want to change the particular rail because of any reason, either the rail is now out of the work, then if the new rail will come, which is come in a particular standard size and length, it will not going to fit in a particular point, because of the creep all the profile get distorted. Okay, so that means it becomes difficult to change the rails. Okay, in some point the new rail become long, or sometimes the new rail become shorter based on the situation. Effect on interlocking. The interlocking mechanism of the point and crossing get distorted by creep, that we have already discussed, right? About point and crossing. Okay, so interlocking mechanism we are also going to discuss in coming module. Fine. Okay, buckling of train. So if the creep is excessive, there is a negligible in maintenance of the track. If the maintenance is very less, then possible buckling of the track cannot, it will rule out the train. Okay, so what is actually buckling of trail? I will show you a picture. What is actually buckling? You can see this. There are many pictures out there for buckling. So they become derailment. You can say they are come out of the alignment. Okay, because of the addition increase in length or in movement of the rail in longitudinal direction, they push the other or successive rail and they become derailed from the alignment. Okay, here you can see, even in the picture you can see the actual line is in this direction, but this line come out of the alignment. Okay, like that. So this is called buckling. Fine. So these are the effect of basically the effect of creep. Fine. Now how can we minimize the effect of creep? One process we have already discussed, right? Adjustment of creep mainly. So prevention of creep. So prevention is always better than cure. Is just statement you can say. If creep is not prevented in time, it will result in derailment. Like buckling, it's a very serious issue. You can say. So following are some common approach that can be adopted to prevent creep, like pulling back the rail, or applying a anchor or anti-creep fastener, or using steel slipper. Okay, because steel slipper in steel slipper, if you use slipper, the rail can be fixed so more tightly with this steel slipper. That's why it where it needed, you can also use steel slipper to reduce the creep. Okay. Now about pulling back the rail, we already discussed, right? So here you can see pulling back of rail. Means suppose one rail is moved in a particular direction, we can pull back in its original position by using some apparatus. Here you can see some apparatus is given here. At but at this point, at this point, okay, wait. So at this point, the machine is fixed, okay, and from this direction, the with the help of this apparatus, the rail is um, pulling back. So here you can see, if you can see closely up to this level, there is a rail. Okay, there is a rail part, and this is the rail part. Okay, can you see here? Can you see this rail part? This is the rail part. This is the rail part, and this is the rail part, and this is the expansion joint. This is the expansion joint. Okay, now that means this particular rail creep in this direction, so we need to pull back in original direction. Fine. So with this, how to do it? Fixed at a particular distance, which is also based. There is a standard procedure how to use this instrument. Okay, so lock this apparatus in a particular rail, and using this other head of this instrument, you can pull back to its original position by giving an appropriate expansion joint. Okay, expansion gap. So if creep is distinctly visible, their remedy is to pull back the rail to their original position. For doing this, first inspect the track. Note the extent of pulling back distance. That how much distance you need to pull back, you have to be pre-decided. Okay, and determine the point from which it began. Now start pulling the rail back to its original position by means of crowbars and hooks provided through the fish bolt holes of the rail. In pulling back, the position of the joint relative to sleepers must be maintained, and both the rail joint must be in their relative position. Pulling back the rail is a very slow and tedious process, and it's only possible when a small length is to be dealt. That means if a particular only 1 to 3, or it's based on their standard procedure. That means it is not deal with the huge or large projects. So for a very small length of maintenance can be used. Okay. It has moreover been noticed that the rails start creeping immediately after pulling back. Okay. So you have to use more proper fastener for that. So before that, before going for this moving, you have to first release the fastener. Okay. Here the man is moving out, pulling out the fastener so that this can be pulled back. It's its original position. Okay. Here you can see different instrument can be used. Here you can see, even here also you can see different separate can be done by using manually. Okay, you can move by giving appropriate spacing. Okay, so these things are already discussed here. Next, you can use an anti-creep fastener. Anti-creep means what? So you all know that the rail is fixed with the slipper with giving a fastening. Okay, a regular fastener. But in some places, you can also use a special fastener, which is called an anti-creep or anchor, which can be used to anchor the rail with the slipper. Okay, and how it look, you can see. So these are anti-creep apparatus. This one is anti-creep. Okay, so they are the anti-creep which are fixed alternatively. Okay, they are simple bearing plate. This one, the very simple bearing plate, can be attached. Okay, So the creep of track can be prevented by using anchored or sufficient creep ballast. Okay, for creep of 7.5 centimeter to 15 centimeter in month, 4 anchored per rail, and for creep of 22.5 centimeter to 25 centimeter, 6 anchor per length are used in a particular Indian standard. That means how many anti-creep apparatus anti-creep can be used in a particular rail length, in a one length of rail. It's depend on the amount of creep, possible amount of creep. So there is a standard that if in a particular month, in a month, if your amount of creep is ranging from 7.5 centimeter to 15 centimeter, then you could use 4 anchor spacing equally in a particular rail, per rail. Okay, and if your creep between this 2.5 centimeter to 25 centimeter, if the creep is about this length, this deflection of rail in a particular month, then 6 anchor you have to go for it as per Indian standard. Okay, so you can also use anti-creep or you can also use steel slipper. Okay, like this you can also use alternative steel slipper or as a whole full steel slipper, since a slipper should be of such type that it's with such fittings they effectively prevent the rail from creeping on them. That means if you use steel slipper, there is a it become easy to fix the fastener, or it easy to anchor the rail in steel slipper. That's why it's also given as a remedy for creep. Where it needed, a steel slipper can be used. So this is all about the remedies, or you can say how to prevent creep by giving pulling back of rail, by providing anti-creep, or by using steel slipper. Okay, is there any doubt till now? So this is all about today class. Okay, so with this we have concluded the second module. So from next class we're going to start the third module. Fine, clear hai? Any doubt? If you don't have any doubt, then I just close this sharing. Okay, I think these notes are already with you. You can also go cross check and go for revision. Also go through the recording video also. Okay, doubt अगर नहीं है तो I'll just stop my recording. Okay, then I'll take your attendance. Okay, okay, I'm stopping this recording.